Good morning, everyone present over here. Respected substitute and all my dear friends. Today is Miranda.
It's me, Shreyans Pradhan.
And it's me, Samikarana.
And today we are here to study about the second part of functions chapter. So let's get started with it. As we is talking about the overall content. So our main topic for the functions is real value functions. This is basically the functions which is such that the image of the function it belongs to a real number, so that it's like image belongs to real numbers, and the function is further divided into algebraic functions and transcendental functions. So about algebraic functions, the group before us has explained a lot about them, but just for a brief explanation, it is further classified into constant functions, which basically is that fx gives a constant value. For example, let's suppose 5, and it is also the other types are identity, which is y equals to x, so it gives the same value as for the pre-image. Linear function, which gives the function in form of an equation, where the power of x is always 1 and the x cannot be 0. Then we have quadratic function, in which such that fx gives an equation similar to this, where the power of x is 2. Similarly, there is a cubic polynomial and rational. Here the cubic and polynomial are self-explanatory. It's the same as quadratic functions, but the power of x changes into 3, and for the polynomial, the power of x changes into any other integer number. For rational, it is a special case, is such that fx is an example of like qx divided by px, where px cannot be equals to 0. And for the main topic we are going to be discussing today, it's translation functions, which is divided into trigonometric function and exponential and logarithm. So in our syllabus, there is mainly discussed about exponential and logarithmic functions, and these two functions are very closely related to each other. So for a simple understanding, let's give an example. So when we say there is 3 to the power 4, what we normally understand, it is 3 multiplied by 3 multiplied by 3 multiplied by 3 equals to 81. So this is what we understand when we say 3 to the power 4. So when we express this in logarithmic function, we explain it as log base 3 81 gives 4. So here we say 3 is the base to which the power is applied, 81 is the result, and 4 is the power that is applied to the base. So similarly, exponential function is 3 to the power 81. So exponential function expresses this term like this. So let's say there is a question, suppose it's like log base 232 equals x. For us to find the value of this, we can also express this in the terms of exponential functions, which basically gives us 2 to the power x equals 32. Then we can also solve this. There is law of indices, which expresses basically like 2 and 2 to the power x, 2 to the power 5. So if the bases are similar, we can give x equals to 5. In this way, Logarithmic function and exponential functions are closely related to each other, and they can be expressed in simple terms in such a way. Now, next, to understand numerical part, I would like to call my friend James.
So I will be solving some important problems from the exercise. The starting problem, the problem I would like to start from is this one. Okay. So for this problem, first we have to separate these logs into the separate. We have to separate these logs into two parts by dividing by using the property of log a by b equals to log a minus log b. Now doing this, we will get something like minus log a 15 28 minus log a 27 plus log a 405 minus log 196. So in order to solve this, first we have to regroup these problems into regroup these logs where into in which it is like, for example, 405 will be divisible by 27, so we have to rearrange them and again recombine them, such as one number will be divisible by another. So we have to do like log a 405 minus log a 27 minus log a 15 minus log a 196 minus log a 28 log a 14. Regrouping like this will help simplify this problem very quickly and easily. Now 405 divided by 27 will be 15. So we can simplify these two into log a 15 minus log a 15, and 196 divided by 28 will be equals to 7. So this can be written as minus log a 7 plus log a 14. Now this and this will be cancelled, and here now we can not this and this will be cancelled, and now we can rearrange this as log a 14 minus log a 7, which will be equals to log a by 2, proving the RHS. Now for the next problem, the next problem is going to be x to the power ln of y minus ln of z times y ln of z minus ln of x, and z ln of x minus ln y will be equals to 1. In order to prove this, we have to first suppose this one as let's suppose this as k. Now if we suppose this as after supposing this as k, we have to take ln of both sides, which will and separate these and using the property of log, separate these into ln x, ln y minus ln z, ln z, y, and ln y to the power ln plus, sorry, ln z minus ln x plus z plus ln z ln x minus ln y will be, which will be equal to ln of k. Now using another property, we can put these powers in front of this ln x and ln y, and it can be written as ln y minus ln z ln x, and doing like this, so on it can be done. And then finally simplifying, after putting this power in front and simplifying this, we will get ln k equals to ln 0, and then ln k ln 0 sorry, not ln 0, will be ln k equals 0, which is ln 1, and then k equals to 1, and we can prove this relation. Now I'd like to hand over the market.
Good morning, everyone. Today I'm here to provide some tips and tricks for these chapters so that you can understand and do the problems easier and more efficiently, and possibly save some marks in your exams. For the first, I would recommend all of you to remember easy exponentials such as 4 to the power 3 is equals to 64, 8 to the power 2 is equals to 64, so that 2 to the power 6 is equals to 64, so that you can do your questions much easily. And for the second point, if you are having a hard time doing logarithms, such as this one, 64 is equals to x, some of you might find it hard to find x. So what I recommend you to do is to convert this into exponential by using one of the properties of logarithm, which is log ax, which can be applied here to make it 64 is equals to 4 to the power x, and then convert 64 into 4's power, 4 to the power x, x is equals to 3. This makes the problem very easy. Now I'll provide you some shortcuts that can make your solutions much easier. Log b by a, is log ab is equals to log xa by log xb, where x belongs to real number. And for the fourth point, log am bn is equals to log ab is equals log ab into n by m. These are the shortcuts that I have provided you for today. Our presentation is over.